Why is the night sky dark? It's a question so deceptively simple that most people never bother to ask it. Darkness is the default, right? Daylight comes and goes, but the night, that's just the absence of sun, isn't it? Not quite. What if I told you that darkness of the night is, in fact, one of the most profound clues about nature of our universe? That behind this black canvas lies a paradox that once shook the foundations of cosmology. Welcome to Olbers Paradox, a riddle that forces us to confront our assumptions about space, time, and nature of infinity. Let us begin with the thought experiment, the kind that physicists are addicted to. Imagine a universe that is infinite in size, it stretches endlessly in all directions, eternal in age, it has always existed, uniform in star distribution, stars are spread more or less evenly across space, and static, that it is neither expanding nor contracting. Now picture yourself looking up at the sky in such a universe. In every direction you gaze, your line of sight should eventually land on the surface of a star, because in an infinite and eternal cosmos filled uniformly with stars, there's no place for darkness to hide. So here's the paradox. Is the universe infinite and eternal? And if it is, why isn't the night sky bright as the surface of the sun? The contradiction is not just poetic, it's mathematical. Every concentric spherical shell around us at increasing distances contains more stars. Even though the stars that are farther away appear dimmer, the increased number of them in a larger shell, compensates for the dimming. The net result? Each cell contributes the same amount of light. With infinite shells, the total brightness should diverge, leading to a sky ablaze with starlight. But clearly, that is not what we see. The night is dark, cold, quiet, empty. So, where's all the light? At first glance, the resolution seems straightforward, as we know that universe isn't infinite in age. It had a beginning, a finite time ago. And that's correct as far as it goes. The universe is around 13.8 billion years old, and light has speed limit. This means that there is a cosmic horizon beyond which light simply hasn't had enough time to reach us. We are looking into a bubble of visibility, a finite sphere. So, we're not actually seeing an infinite number of stars, we're only seeing what's inside this observable universe, a kind of light speed echo chamber limited by the age of the cosmos. That's already a powerful resolution. The darkness of the night sky is not failure of physics, but the fingerprint of cosmic youth. But the story does not end there. Even if the universe is finite in age, shouldn't all that starlight within our cosmos or cosmic bubble eventually reach us? Here's where things get interesting. Universe is not just sitting there, it's actually expanding. It was the discovery of Hubble itself that universe is not static, but the galaxies farther away are moving faster. Universe is expanding, not just drifting around like dots on a bubble. It's expanding in a way that affects space itself, stretching the very fabric that carries light. This expansion causes what is called a redshift. That is, as light travels through the expanding space, its wavelength is stretched, which reduces its energy. What begins as visible light now arrives as infrared or microwave or even longer wavelengths. In fact, the cosmic microwave background, that famed 2.75 Kelvin radiation bathing all of space, is the ancient light of the early universe stretched over a billions of years from blazing photons into a cold whisper. So when people ask, where is all the light? The answer is it's here, but it's too red and too stretched for our eyes to see. This is the deeper resolution of Olbers Paradox. The light hasn't disappeared, it has just been diluted, cooled, and redshifted by the expansion of space. Olbers Paradox is classic case of why is there nothing? A question that turns into, let's just say, look how much something that nothing tells us. Well, in principle, the darkness of the night sky revealed through the paradox that universe should have had a finite beginning. And it must not be infinite in age, and it should probably be expanding. Most of the light from the early universe is invisible to our eyes now. Cosmos is still glowing, just not where we can see it. So the paradox isn't really a paradox anymore. It was a portal through the pages of history, a gateway that opened up into Big Bang and cosmic expansion, thermodynamics and general relativity. All from the simple fact that the night sky isn't bright. Isn't it ironic? The absence of light turns out to be the loudest declaration of the universe's birth. In poetic sense, Olbers' paradox is like a cosmic koan, something you meditate not to find confusion, but clarity. You often think of darkness as ignorance, as absence, but in cosmology, darkness is information. It speaks of time, finitude, and structure of reality. Next time you look up and see dark's canvas of night, remember you're not looking into the emptiness. You are looking into a question that once confused the brightest minds and into an answer that rewrote our understanding of the cosmos. Darkness, it turns out, is the universe's most honest storyteller. Thank you guys for watching. Make sure you follow and subscribe for such fun videos. Thank you guys for watching and make sure you subscribe for more.